Hi, um, this video is based on the explanation of the Namaz posture recognition system. So we will explore the three files which have been used in the Namaz posture recognition system. We will first start with the z.py, which is basically based um, on Raspberry Pi file getting the data from the camera module and then do um, run the deep learning model on it and then pass the data to the Bluetooth video. So we will first start with the library. The first library is known as CV2, which is the computer vision OpenCV library for the computer vision functions. Then we have another library named as threading, which is not used in the program, but in the future, if we want to do the multi-threading, we can use this library. The other three libraries are related to the cloud model, which is based on the IBM Watson Studio. So these are the important files which is used to deploy the model from the cloud. Then we have another library known as time, which is used to calculate the time lapse in the function, and then the serial for communication development. We have now a function named as port, which is basically we are creating object by passing the baud rate 9600 and the RF form for the Bluetooth module XC05. The things in the comment we can ignore it. We will be using the functions step by step in the while loop. We first authenticate our model uh, with the Watson authentication function, in which we basically authenticate and communicate over Raspberry Pi with the IBM Watson cloud model. So let's explore the Watson authentication function. So in the Watson authentication function, we pass the API key, version and words are the credentials, and after passing it, when it gets authenticated, it prints the message as well and return the visual recognition object. After this, we have another function named as cap.video capture, in which the video address has been given. You can use it if you want to run it on any recorded video, then you have to comment the next one. Otherwise, if you have to run on the Pi camera, then the latest frame using this. Uh, this is the image file has been used to save the every frame because the IBM Watson model only takes the file in the logical form. So we have created a file here in which we will, or every time we will write the same file with the same name. The next slide explains the FPA of code. FPA is the frame per of the camera. And we have a here of the four elements, and then we have a max portals, which are and we can ignore the interface right now we use the program. So let's start the loop here. First, it takes the initial value from the start and then it's read the category, then it's a resize it to 320, then it's start putting it with the name of the image file. After this, we will go towards the result, in which it's basically get the prediction from the IBM Watson model. We are passing here object of visual recognition and object of the past from IBM Watson, and we are passing the collection ID, which is related to the deploy model collection ID, credentials, and the image file address. Let's go to the get result. So in the get prediction functions, we are basically opening the image file first with the path, and then we are getting the result from the visual dot analyze function, in which we are passing these three parameters and the result JSON format. After getting the result from the JSON format, we basically extract the 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 identification that whether the object has been detected or not. If the object is not detected, then it will just pass the frame. Otherwise, it will store uh, the the values or the information of an object into the outcome, and then we get single score and single label from this. After this, we print the label and store the confidence score, and then we pass through the window. So how this window works? So this window works in the first and last of the method. So let's in this function in the whiteboard. So let's say there are indexes 0, 1, 2, and 3, and in the first 4 frame, the poster Qayam has been detected. So, for example, now if a Ruku has been detected, so what will happen? So the Ruku will come here, and it will push all the the previous elements to the next. For example, now this Ruku will come here, this Ruku will come here, this this Qiyam will come here, this Qiyam will come here, this Qiyam will come here, and this Ruku will come here. So eventually it will become R Q Q Q. Now, for example, if the Tashud has been detected, so the Tashud has been come here, Ruku will come here, Qiyam will come here, and this Qiyam will come here. So it will be like Tashud, Ruku, Qiyam, and Qiyam. So first in and last out. Let's move towards our code again. It's pass the Windows data to the Bluetooth send data function. How the Bluetooth send data function works? Let's see. So the Bluetooth send data simply takes the window. It sets the value data to the 10. So it checks the two things. First, the count of the posters, the number of posters should be 2 in a window. And also the first two elements should be the same. For example, if the Qiyam has been detected in the real time, then in the window the Qiyam should come twice and on the first two positions. Otherwise, we will not detect it. These parameters has been tuned and set according to the real-time scenarios. So it's passed the data 20, which is mapped to the vibrations of the Qiyam thing, and then passed 30 for the Ruku to the Bluetooth, through the Arduino Nano. It is Sajood for 40 and Sajood for 50. And then after setting the data, it set the data to the string and write the data, transmit the data to the XC05 Bluetooth module, which is further connected to the Arduino Nano, and then if it's received, then it's received the function that the data has been transmitted. We have now another function after the Bluetooth send data. So let's see. So the object has been detected. After detecting the object, we have already sent the data to the Bluetooth module as well. Now let's come towards the visualization on the camera. This step is um, optional if you only want to get the signal on the receiver data and not want to visualize on the 5 frame, then you can exclude this. You can exclude. All right. So it's basically takes the bounding box of the image. For example, if someone has doing the Qiyam poster, so it will draw the bounding box around the person. It gets the initial x and y values and the width of the bounding box and the height of the bounding box, and then it um, gives the all the things as a parameter to the generate results function. Let's also explore the generate result function. In the generate results function, we are basically passing the image in array. I think there is an image path has been written in your program. You can change it to the image, and then it is passing the confidence score and the label and the bounding box information. It sets the font. If there is a Qiyam, then the red bounding box will appear, green for the Sajood, yellow for the Ruku, and blue for the Tashud. This is the Qiyam and Ruku at standing position. So for this one, we are basically getting the annotations of the confidence score and label on the right side. Otherwise, in the case of Sajood and Salam, we will get on the top of the bounding box. The confidence score is less than 0.4, then it will label it as unknown. All right. Then it's basically takes the confidence value to the up to the two floating values with the two decimals, and then it's write the final text and we draw the bounding box here. Then here we basically put the text on the bounding box, and it's return the image again. And the returned image is basically shown as the frame on the Pi frame in the Raspberry Pi. Now, if the object has been not detected, then it just only show the open the bar frame on the window. After that, we are basically taking the difference from the current time to the start time to get the time lapse and print it. In this function, if the Q key is pressed, then it will exit from the processing. After that, it's release the camera. It may turn off the camera, and in the destroyer windows, it closes the frame window. Let's come towards our next uh, function program, which is enable H05. So this program must be open in the separate terminal in the Raspberry Pi. It means that Pi should be run in one terminal and enable H05 should be run in another terminal of the Raspberry Pi. It should be run continuously, it should not be closed. It just have the physical address of the current Bluetooth HC05 module which is connected to the Arduino Nano. If you want to replace the Bluetooth module, then you also have to change the physical address as well. It's just pass the command line function sudo rfcom connect HCI0 to the physical address one through the OS system library of the Python. So from the Python script, we are basically passing the command line function to the terminal. It will start the Bluetooth communication with the HC05. Then we have the receiver side program, which is known as Bluetooth receiver. We are basically setting the constants here with vibration pin at the pin 4 and melody at pin 12. Similarly, the Ruku at 10, Sajood at 8 and 6. So Qayam melody is regarded as red LED, Ruku is as yellow, Sajood as green, and Sajood as blue. We have two functions here, blink LED and vibration, which we have defined and declared here. In the setup part, we are basically setting the portrait to the 9100. And here we are setting the Qayam spin mode of everything at the output. In the loop section, it's first listen the data from the Raspberry Pi, and it's first see that if the data has been transmitted or not. If the data has been transmitted, it's convert the data into the numbers. And after converting into the numbers, it's see that if the value is greater than 0, then it shows that your input is that thing, and it passes the integer to the blink LED function. In the blink LED function, it see that if the past value is 20, if the past value is 20, then set the Qayam pin high. We can see that we have passed. We see that we have passed 20 in the when the Qayam has been detected. So when the 20 value is passed, the Qayam LED will high, other will be low, and the vibration will be set to the 300 milliseconds for the one time. The vibration function is here. And the vibration function is simply taking the delay time and the loop counter. So we are setting delay time to the 300 milliseconds and loop counter to the 1, 2, 3, 4. For the Ruku, it is setting high LED, Ruku LED is high, and other are low, and vibration are set to 300 milliseconds for 2 times. For the value of 40, you can see that 40 value is mapped to the Sajood. So for the Sajood, for the 40 value, the Sajood pin is high, other one is low, and it's set to the vibration to the 300 milliseconds 3 times. Similarly, for Tashud, setting vibration for 300 and 4 times, and only Tashud LED is high, other ones are low. So this is a description of complete system of the software programming of the Namaz posture there is anything required to be asked, so you can ask me any question anytime. I would love to answer.